In this video, I'm going to show you how to process the data that you've downloaded from the AX2 devices. So, open the interface, and at the lower edge of the screen, we'll see all the files that you've downloaded into your current working directory. The workspace line here shows you which directory you're currently in. The dots at the end will let you choose to work from another folder, and this middle button here will let you open that folder in Explorer to see all of the files. So as you click through the different files, you'll see that the central preview pane shows you a preview of what's in those files. You can use the tools on the right hand side to show to change what part of which bits of the preview are shown. So for example, I can toggle some things on and off. And then you can use the tools to actually zoom in or zoom out of the data that you'd like to see. So, when we select a file, we can choose to perform some calculations on that file. One of those things that we can do is to export the data. The files from the device are in a format that's suitable for recording this data in a compact form on the device itself, but a little bit difficult to work with in other applications. The export tool can make it easier to use the data in other applications. We can export data into a WAV file, which is a standard audio wave recording. This option is very suitable for especially larger recordings that tend to be with a higher sample rate over a long period of time, because other formats are text-based and a WAV file is binary, which means the files are more compact and much faster to open in other applications. The next option for exporting is very similar, but instead of a sound file, it actually saves it as a text, comma-separated value file. And the final option doesn't perform the same resampling and just leaves the data at a recording frequency which is determined by the actual sensor itself. This is the sort of the raw underlying data that the device captures. The resampled option is usually preferable for most applications. First of all, I will show you they're exporting raw CSV, in case this is suitable for you. When you select that, the first thing you choose is to name the file. It'll default to a name which is the same as the input file name. And then in this export raw data dialog box, you can choose the units. Gravity units of G are probably the most common to use. And the format of the timestamps on the right hand side here. So you can choose between having no timestamp, just the sample number itself, formatted date and time, the number of seconds relative to the start of the file, the number of seconds relative to the unit's epoch of 1970, the fractional amount of days relative to the start of the file, or the fractional amount of days in the epoch that Excel or MATLAB uses. And then on the left hand side here you can choose to subsample the data. This may be useful if you don't want to export at all. In the interface actually, this will make use of the range select button in the options over here in the preview window. The values will be imported into that. And finally hit the convert button and your file will be converted. So we've been working in the data files tab. There's also a plugin queue tab, which is used only by sort of external plugins, which we won't be covering in this video. And then finally the output files tab will show output files in this folder. And here we can see the CSV file, the comma-separated value file that we've just exported. So the other options for exporting are the WAV file, as I mentioned, and a resampled CSV file. So I'll just show you both of those. They're fairly straightforward. You choose the resampling rate. The default of auto means to use the same sampling rate that the accelerometer was configured for. You can override this by selecting one or just typing your own value. And then an auto-calibrate option, which uses the data itself if it's a long enough recording and other certain criteria met to sort of calibrate the sensor itself from the data itself. And then hit the resample button. And that will show you that it's actually outputted this WAV file. And the same applies for exporting to CSV. It's the same process. You choose that you're running a value for CSV. And also, other options include processing on the actual file itself. So, for example, we can export a scalar vector magnitude file, processing of the cut points, wear time validation, or sleep analysis. These are just some of the built-in calculations that can be performed. From the raw data you've exported, though, you may be able to find tools that can use that to perform the exact calculation that you'd like to perform. I'll go through these other options now for the calculations. The first is the scalar vector magnitude. This has options about, first of which is the epoch setting in units of seconds that you'd like to set it to. So the default value of 60 seconds will give you 1 minute epochs of data. You can override that to be any amount of seconds or choose from the drop-down for common values that you may want. Next option is the filtering option that is to be performed on the raw data. The common choice here is a bandpass filter of between 0.5 and 20 kHz, or you can choose to not perform the filtering. And then the final option for calculating scalar vector magnitude is how to deal with the values that go less than 0, because the scalar vector magnitude is after -1 Gs. So with the negative values, you can either take the absolute value of them or simply truncate them. So here we're going to leave it on default of taking the absolute value. Perform the calculation here, and it's showing that it's output the file successfully. And again, that file will be here in the output folder. Okay. The next analysis we can perform is analysis of cut points. If you'd like to see information about what this analysis is actually based on, then go to the website, Open Movement GUI, and follow the links to the AX3 graphical user interface. And in the web page, further down, it will describe in a lot more detail how the what the analysis is based on. So back in the interface, again, you have a choice of cut points. For the cut points analysis, you can choose which epoch, which is based on a 1 minute epoch. You can multiply that to a scale of that. You can choose which model it's using, so which set of cut points it's actually choosing to use in this drop down. And you can finally choose the filtering from raw data. And then at the end, you press run, and it will have calculated that output. You put the file again in the output directory. So an additional item here for to calculate the data is the wear time validation. So clicking the wear time validation link, the only option we have here is to scale up the number of epochs. So here we have half-hour based epochs, and you can choose to multiply that up into larger sets of that. And then you choose the one that you're happy with, and press run, and it calculates the output here. The final built-in analysis is a sleep analysis. Click the link for sleep analysis, and there aren't any user-defined options for this process, so just simply run the analysis. And again, the output exists in the output files down here. And that's it for the built-in calculations. But as I say, the export allows you to find all sorts of other calculations that can be performed on the accelerometer data itself. Thank you for watching the video, and refer to the website if you've got any additional questions.